Oh. Hello everyone and welcome back to Arctic Retro. So today I'm a little bit excited. I just got this one, the Commodore 64 obviously, and I bought it here locally from a seller who doesn't know anything about it, if it's working or not. He just sold it for his father, and yeah, we need to take a look at it, see if it's gonna be a restoration video or a repair video, I don't know. And I also got a bag with some other stuff with the machine, so I'm gonna check out that too. So let's just go right ahead then and see if it even powers on. Always fun with the Commodore, that's my favorite machine if you don't know already. So this is what came with the machine, a couple of pads, cassette player, very yellowed, it's Fuji-Sonic branded, seems to be in a good shape. Another joystick, Spectra Video Quick Shot. And a Le Mans cartridge, cool. And then you have English and Norwegian user manuals. Then the machine, the box, yeah, it has seen better days, but it's fairly good still. I have worse than that. Yeah, some of the styrofoam is broken off. Machine looks very good. Oh. Well, a loose badge, that's easy to fix, but otherwise looks to be in perfect shape. A little bit yellowed perhaps, but not much. This video is sponsored by PCBWay. If you need to have produced your own PCBs, then just visit PCBWay and you can get an instant quote for your own PCBs produced for as low as $5 for 5 PCBs. They also do other stuff like advanced PCB. They do CNC machining and 3D printing, sheet metal fabrication, and prototype PCB assembly, among other things. Also visit their shared project site where you can find a lot of already made PCB designs. So go ahead and visit PCBWay.com and check out their services. And of course the original power supply, which some say can be dangerous. I do prefer to use a modern variant for the Commodore 64. I have a couple I bought that works fine, but I'm gonna check this, see if it is working and what voltages it has. It's 5.2 volts, and that might be a little bit high, but I think it's okay. And the AC 10.6, yeah, that's good. Then I'm gonna hook up the machine and I use this modern power supply for the Commodore 64, and yeah, it has been very good. It's from Keylog, I think it was. And the badge also fell off. Need to fix that. So when I buy these old Commodore machines that is in unknown condition, I actually hope that they're not working, so that I have something to do and fix. Let's see this one then. Yeah, looks like I've been heard. There's nothing there. Black screen. The power LED is on, and it actually produces video, but no picture. If there was no video signal, then the TV would say no signal or something like that. Alright then it's time to do a little bit of inspection inside and see if it's an easy fix or not. Also gonna do some cleanup. It has a lot of dirt and stains. So I think I have maybe 10 Commodore 64s in various types, but no, I think I need to start shelling something because I don't have much room left. The screws they feel like they've never been taken out. So yeah, what do we have here? Yeah, seems like this has never been opened. The clips were not stuck. Has this old paper, metal paper shielding, and we have a regular 250 407. So it looks rather untouched. However, there's two chips there in socket. That's a little bit unusual. Every other chip is soldered to the board, and that's a pain. Even the SID and the PLA, a little bit dirty inside as usual. And this is the box for the VIC-2. That's an old ceramic VIC-2 chip. So this is really an old timer. It says copyright 1983, but what does the chips say? They say, in fact, 83, 83, 83, 84, 83. So this is probably made in 1984 then. Yeah, I'm gonna take apart the whole machine and remove the motherboard and the keyboard because I want to clean up the plastics. Actually, the other day I lost one of my Amiga 500s from the shelf and down to the floor, and yeah, let's say it like this. The plastic didn't survive that fall. So I have a lot of pieces to glue together now. Yeah, removing the motherboard is easy. Just take 6 or 7 screws. Yes, and this one I just throw it in the garbage. I don't think it's necessary to keep. I even heard that it makes more heat in the machine if you have it. Okay, then let's do the initial fault investigation here. First check the fuse, although I think it's good. Yeah, it's good, because there was light in the LED. I think if the fuse is blown, then there's no light in the LED. Then I usually check the voltages and start with the voltage regulator, and it's 4.96, 11.3. Oh, 3. Oh, I just heard like a spark. Did I accidentally short something? Yeah, and the 12 volt is 11.9. So that's good. And I also usually check the cassette port, see if it has 5 volts, which it has. You can also check some pins on the user port. And then check some of the chips, see if they have voltage. Yes, they do. Yeah, so most likely with a black screen like this, it's one of the chips, obviously. That's not working anymore, and most likely it is usually the PLA chip. That's this one, and this can easily be replaced with modern variants. The SID chip too can be replaced with the modern variants. The CPU has gotten a modern variant also, and the CIA chips can be replaced too with modern variants, and the RAM can be replaced with modern variants. So it's mostly the VIC-2 chip that isn't replaceable by modern variants. However, there is the Cavari, which is a replacement for that. It's a little bit expensive, and it's big, but it's apparently very good. I have not tried the Cavari. I just seen videos about it. And obviously the logic chips, the 74 logic chips, can be replaced with the new modern variants. So one method of fixing this is to start replacing chips with known working ones. However, that's a little bit boring, and you do a lot of unnecessary work potentially. And since these all are soldered in, it's better to try to figure out which chip is gone first. Let's try and turn it on again. Sometimes these can come to life, but no, not this time. So first I'm gonna try the dead test cartridge. It can indicate what the fault is, if you're lucky. Nope, there's nothing. Yeah, it blinks 2, 3, 4, 5, 6, 6 times. So then we need to look up what the 6 flashes means. I tried again and now it didn't flash at all, but here's the manual for the C64 dead test. Yeah, and according to the manual, if we have 6 flashes, it's U22. But it's different according to the revisions, revision A, B. But this is RAM errors. Yeah, so now I don't get any flashes at all. And according to the manual, that can indicate that it's a defective microprocessor or PLA or a VIC chip. So that didn't really give me any help at all. Let's try the diagnostics cartridge for fun, even though it needs more of the machine to be able to execute. Nope, it didn't do anything. I'm gonna leave the machine on for a while and see if anything gets hot. So yeah, the PLA and the SID is quite warm, almost too warm to touch. CPU, not so warm. Oh, this one is quite warm. But none of the RAM chips. So if a RAM chip goes very hot, then it can be an indication that it's gone and has some internal low resistance or short. These chips here are almost never any warm. It's out with the oscilloscope then to try to figure out where the fault is. First I'm just going to try and take out these chips and see if by chance it could be those. Probably not. It's the same chip, so just swap them around, see if that makes any change. It's the 74 LS257. That's kind of strange. 257? I don't think I have spares of those. Maybe they're just more common than I remember. No change. Yeah, let's hook up the oscilloscope and see what it tells us. I mean, the dead test said U22, which is this one. So we can obviously check that. Oh, there's clearly something wrong here. I just get a very low signal. No, sorry, I had the probe on 10x. Yeah, that looks more normal. So this is on the memory chip. So it looks alright to me. On the CPU. Yeah, it looks to be good activity there. Yeah, so I'm gonna go through all the various data bus lines and the address bus lines and see if anything is missing. So I did a little bit of probing around everywhere and I couldn't see any particularly problematic signals except for this chip here on this pin. Yeah, that's a strange signal, just over 2 volts. Yeah, so that's just a sawtooth signal. Yeah, 2 volts. On the other chip, the same chip, it looks like this. That's normal. I tried to swap the chips and see if we see the same if I swap them. Yeah, swap the chips. I know it's the same strange signal from this chip. So that means it's not the chip itself, but something going into the chip. I'm gonna check the schematics and the datasheet for this chip. It's a multiplexer and pin 14 is an input. So we need to figure out where that input comes from and why it is such a strange signal. pin 14. Yeah, here's the schematic, and U13 pin 14 is address line 12, and address line 12 on the CPU is pin 19. Let's look at that. Yes, it's the same. So then maybe we have a faulty CPU. That's always plausible. That's address line 11, and that looks normal. 10. It could be some other chip producing a bad signal. Address line 12 also goes to the PLA chip on pin 25, I think. No, 27. And it's the same weird signal there too. Yeah, right. The CPU is responsible for generating the address bus, and yeah, when it runs code, it puts bits onto the address bus to address the memory, and that makes me obviously suspicious about the CPU. So that's the first thing I'm gonna remove and check. It's Sunday today, and the weather is bad, so just staying home, enjoying this Commodore 64 repair, and with a little Swedish Småland beer. Firing up the trusty old SETI 915 desoldering station. Yeah, desoldering components on these Commodore motherboards are usually easy, but just add a little flux first. Yeah, and it usually never comes loose after the first pass, which is the case here too. So yeah, it actually came loose. Yes, just be careful not to rip any of the pads, but I think all pins are loose now. Yes, that was easy. Now I want to install a socket, and just gonna clean up all the solder pads before. Use some solder wick or braid. Just to suck up the old solder. Clean up a little bit. Yeah, and I do the same on the other side as well. Now find a 40-pin socket. I think this is it. Yes. Just some blue tack to hold it on. Then some soldering action. I solder the two corners first, then I push it up so it's sitting there firmly. Yeah, that looks good. It's strictly not necessary, but I like to remove the flux after soldering. Alright, let's see if I can find a spare 6510 CPU. I think I have one. If not, I'm gonna borrow one from another machine. This one says CPU, but I cannot see the actual label, but I think this is 6510. Just clean it off a little bit on the pins. Alright then, let's see. Was it the CPU or am I completely wrong? One flash, I have the dead test cartridge in, but no, apparently that was not the case here. Let's see without the dead test. Nothing at all. Alright then, let's see if we still have that strange signal on A12. Yes, we still do. I mean, this is A12. You see those sawtooth patterns there, and yeah, but no, it's different. There's some other signal too, and even A13 has the same, but some of the other address lines seems to be okay. Maybe I should have checked a little bit more before, but I get some weird signals from the PLA. Just yeah, it's like it's floating under 2 volts. Yeah, see that? Oh, yeah, it's just 1 volt on some of the pins. Alright, I'm gonna desolder the PLA chip, which is often the cause of these kinds of faults. Desoldering the PLA, and while I'm at it, I'm gonna desolder the SID chip as well, because it is often damaged and need to be replaced anyway, but so it's gonna be good to have it in a socket. These were a little bit harder to desolder, I don't know. Yeah, they're still stuck, so I need to go over with some, maybe some solder wick or hot air. There's some leftover solder on this side, so just try to remove that. Push it in against the pins. Oh, it's still stuck. Oh, this one is loose. Yeah, that's good. That's the PLA, so that's the one we want to remove, but the SID chip is still making a little bit of resistance here. Just try to loosen all the pins from the sides of the holes. Most seems to be loose, but some are stuck. Yes, there were a couple of holes that wasn't really cleared, so I just added some new solder and yeah, try to clear them. Yeah, that's better. Let's see now. Yeah, now it's loose. Great. At least one side. You should never use force, because then you might risk damaging some of the pads or rip traces. It's still hanging on one pin, I think, at least. Yeah, so I'm just gonna clean up all this, and then we'll check with another PLA. Two new sockets. I'm gonna leave out the SID chip because the machine can run without it. However, this SID can actually take down the Commodore 64. And then I'm gonna find a PLA chip. I think I have a spare here, or a modern variant. Yeah, this looks to be right. No, that's the C64C. Can't use that. Here I have a C64 PLA, and this is a modern variant. It's a replica. It's made, I think it's a FPGA chip, but this works great. Okay, it's in. Let's see now. Ah, no. This is a hard one. So it must be something else that's making havoc on the address bus. I'm gonna try with the original CPU. The original CPU is in. Nope. So it's something else then. So I inserted the test card and there's no blinking at all. So I think I'm gonna just try with another VIC2. I mean, obviously it produces a signal, but it could be faulty. Yeah, I actually got a spare VIC2, which is the same type, gold pins and ceramic. Kind of cool chip. Gonna try with that. Yeah. Nope, it's not that. That didn't help. Okay. Yeah, still have that strange signal on the address line 12 and 13. My next hunch then is it's something to do with the RAM and the control logic for the RAM. There's some chips here that is responsible for the RAM and the multiplexing of the RAM. Already checked these. I'm gonna check these in the chip tester and see if they're okay. This is the Retro Chip Tester Pro. You know, if you have some fault with the address bus or data bus, it can be hard to identify what's the cause because so many things are connected. 257, 2-in-1 multiplexer. Yeah, that's good. Check the other one. Yeah, that's good too. Alright, I'm taking a break from the motherboard now because I want to clean up some stuff and also want to refurbish the keyboard. So I'm taking off all the keycaps. It's quite dirty under, but not the worst I've seen. I just want to check if any of the springs are rusted. But so far they look good. If you want to remove keycaps a safe way, you should have a tool like this. I think I paid like $1 or $2 for it on eBay. What you not should do is to try and use a screwdriver and try to pry it out like this sideways. Then you will risk breaking off the keyboard, the key stem. So you need to pull it straight up. So that's not too dirty, a little bit dust. I don't think this machine has been used a lot, even though it's faulty. So I'm not going to stop there. I'm going to remove the whole back plate here and take it off. And that gives me access to the keyboard stems, which has those little rubber contacts on. Because often what happens is that the metal or the rubber contacts get some oxidation or some dirt and they stop working or working less good. So I have a technique for reviving those. I'll show you in a minute. And don't worry, I'll be back with the motherboard soon. Before taking off the back PCB, you need to desolder these wires for the shift lock key. Yeah, so now this can come up like this, and yeah, it looks quite nice and clean. I haven't tested the keyboard, so I don't know if it was good or bad, but still I'm gonna clean it up because I know this can be problematic, and the PCB I just use this kind of cotton swab with a little bit of alcohol, IPA. Or you can use regular contact cleaner. Yeah, so those now look very shiny. Now for reviving these plungers, they have these rubber contacts. You can try and clean them off with some IPA, but I'm not sure if that's healthy for the rubber. However, I found that if you just rub them against some regular copy paper like this, it leaves behind a little bit black, but that's the trick, to remove the outer surface of this rubber pad on the plunger. So that's what I'm gonna do to all of them. I've done that before with a very good result. It might seem like a lot of work, but you do it in 2-3 minutes. I'm sure if you rub too much away, then it's not gonna be good, but yeah, I've done this several times with success on bad keyboards. So now I can take the whole plastic cover here and clean it up in water, but I'm gonna take out the shift lock key because I don't want to get the water inside that. Now this cleaned up very nicely and I can assemble the keyboard again. If you raise the keyboard plate with something on the edges, it's easier to insert the keyboard plungers. Try not to touch the rubber pads with your fingers if you don't want to have any fat or anything dirt on them. Put this back together again, just resolder these pins and put in all the screws and we're good to go. That was it. Now I'm just going to take all the keycaps down to the sink and clean them up in some hot soapy water. Alright, now everything is very clean and nice. I cleaned up all the keycaps, good as new. That snap sound is very satisfying. Yeah, that was it for the cleaning. I'm still gonna try and fix this machine, hopefully, and back to the motherboard. I've been poking around a little bit more thoroughly now, and I actually noticed something else. One of the data lines seems to be bad, pin 37. It looks like this, so it's very low signal there too, 2 volts, and the neighbor pin, it's more normal. That's up on 4 volts. And the 6510, it's pin 37, that's D0. That's the first data line. And I checked with the other CPU as well, it's the same there, so it's not a faulty CPU, it's something else that's holding it down. So obviously the RAM is connected to the data bus, and I now checked all the pins on the RAM chips, and out of all the 8 only this one stands out. It has a very low signal on pin 2 and also a very low signal on the third pin on this side. So that's pin 2 and that's pin 14. And the rest of the pins are good, and pin 2 on the other chips as well is good. And what do we have on the RAM chip? Pin 2 is data in and pin 14 is Q. If we take a look at another pinout, it's described as D in and D out. So I think we have maybe a bad RAM chip here. I mean, if the input signal was weird, then I think the output signal would be more normal or not present at all. But seems something wrong with this chip. So I think I'm gonna replace this one. One thing you can do is to use the piggyback method, where you have a good RAM chip, just place it on top of a bad one, and if you're lucky it could work. Yeah, I think I placed it correctly and it sits well there. Just gonna turn on and then measure pin 2. Yeah, the signal is a little bit better now. It's up on 3 volts and out. Same there. However, if there is an internal short or something in this RAM chip here, it might still be able to drag the voltage down on that signal. So yeah, the best thing is to just remove it and replace it with a working one. Let's get it out. Yeah, this came quite easily out too. Alright, let's see now if I hook up the board without that chip, see what happens. If it releases the problem on the data bus. It's a D4164C2. D4164. Yeah, 64K times 1. Yes, it's failing. Sometimes it can have bad contact. Oh no, it's not failing. Some assumption is wrong then, as usual. Yeah, it's passing all the tests. Anyway, I'm gonna replace it with a new one, just to see. Test passed. Let's check the new one. Passed too. Alright, in with the socket. Let's see now. Yeah, it's still the same. It's same very low signal on that pin. Okay, I think I need to check then some of the logic chips here because they are responsible for multiplexing the RAM and stuff like that. Well, according to the schematics, pin 2 and 14, as we already know, is in question here. They just go directly to the data bus D0. And almost all the chips are using the data bus, so then it's a little bit difficult. We checked the VIC, we removed the SID, and we have replaced the CPU and the PLA. So what do we have left then? We have the 3 ROMs and the CIA chips. And I have had machines with faulty ROMs, so that can happen. So D0 goes to pin 9 on the 3 ROMs. Yeah, it's the same there, obviously. 2 volt signal, but the others are good. That makes it hard to know which, if any of those are in fault. Obviously, if they were in sockets, then it would be easier just to take one out, check, see if we saw an improvement. And it can, of course, also be the CIA chips, but most usually they break and just makes the machine a little bit faulty, not like this with black screen. I was thinking, since the voltage seems to be low on that line, let's measure for short or resistance. Let's see. If I measure from ground to D0, Yeah, there's only 1.1 kilo ohms. Seems a little bit low. Let's check some of the other data lines. Yeah, that's 6 mega ohms. 6.4 mega ohms. 5 mega ohms. 6 mega ohms. Let's check on the CPU then. 37. 1.1K and D1. 5.7 mega ohms. That's a big difference. So something is shorted somewhere, but where? But not completely shorted, and apparently not enough to make any stand out as particularly warm. Yes, I know that the board has been powered on for a while. There's only 120 ohms, and the other lines has 4.4 mega ohms. So what I'm gonna try to do is measure between the various data lines on the various chips, D0 and ground on the chip, and see if we can see any particular difference in the resistance. This is just an attempt to avoid desoldering in the chips. So try the first ROM, and there's 133 ohms and 134 and 135. So this one had the lowest resistance, but the difference isn't that much. I actually asked ChatGPT and I explained the problem and the motherboard revision and everything, and it says here most likely culprits: faulty ROM, CIA chips, or the 257 multiplexers, or a short on the board. No, I'm not entirely sure that this CPU is working, so I'm going to just remove it, check the resistance again. Yeah, it's the same, so it's not coming from the CPU. I'm also going to take out the VIC2 and the PLA chip, just to see if there's any change in the resistance. No, still the same. Alright, so then we're left with the 3 ROMs and the CIA chips. So it's going to be a guess. It could be some dirt or short on the board, obviously. I'm going to take a close look. Could potentially be a shorted or a bad capacitor somewhere. But the caps are mostly between 5 volts and ground, not on the particular data lines. By the way, I swapped the 2 multiplexers just to test, and still it was low resistance on the same chip. I mean D0. Alright, so there's not much else I can do then, just remove. I start with, I take all the 3 ROMs, just because it's nice to have them socketed, and then we see if one or more of those are bad. I'm gonna quickly desolder these 3 and then I'll be back. I'm just gonna stop here now. I took out first the kernel ROM, or this one, I think that's the kernel, and I checked the resistance, it was the same. Then I took out this one, which I believe is the character ROM, and look at that. The resistance now is 6 mega ohms, and on the other one it's 5.6. Yeah, and if we check, let's see if we check the resistance on the chips themselves. This is the kernel ROM, and it's 6.6, yeah, 6 mega ohms, and this one 170 ohms. Yeah, so this is faulty then. Nice. So I'm just gonna leave this in unless it's faulty too. Now in with some sockets. I only have this turn pin sockets, or what they're called, with the round holes, but I don't like them. Actually, they don't work very well with desoldered chips, but that's the only one I have. And the reason I don't like those sockets is because when you desolder chips, there's always some leftover solder on the pins and can make them hard to insert correctly. It's like they have some hooks also because they've been bent. Yeah, I'll see how that goes. It doesn't go right in. Yeah, I need to fiddle around with this a little bit more, obviously. Yeah, it finally went in, but the pins need to be very, very straight in all directions. Okay, let's test. I believe the machine should start up without the character ROM, only it will show garbage. However, the dead test should work without the character ROM, but there's nothing. Let's try the dead test now. Yes, now we're talking. At least there's some life here. So let's see what the dead test can tell us. It seems to be okay with the RAM, and the color RAM seems to be good. CIA chips timers seems to be good. I didn't insert the SID chip, so it won't play something on that. So it didn't tell us anything else. I'm going to try the diagnostics cartridge, which tells us more if it can run. Ah, I'm sorry. The middle ROM is the kernel ROM. So we have a faulty kernel ROM. I have a spare here. This is one more modern variant in an adapter. So it uses a 27C64. However, this has thick pins and those don't fit into that socket. If I hold it hard, turn on the machine, did not help. Actually, I found an original kernel ROM in my spare parts box. See if that will go in. So obviously without the kernel ROM, then the machine will not start. No, it's impossible. That's why I don't like those types of sockets. I don't know, many others seems to be enjoying them more, but me not. It won't go in, or the legs are simply too short. I think that might be the case. Okay, let me do a trick then. Let me just use another type of socket inside that socket. This is a normal type. I'm just going to insert this one first so the pins won't pop up. I have no idea what kind of socket that is. Oh my god, that's not a socket at all. It's just blanks in the holes. You cannot insert anything there. Crazy. I didn't notice. It just looks like a regular socket. No, it's impossible to insert anything at all. I don't know what that kind of socket is used for, but obviously you cannot insert anything. No, the holes are just very, very short, maybe 1 millimeter. Oh boy, just need to desolder this one again then. Well, I'm gonna solder this one then. It's a little bit longer, but that doesn't matter. I just take out the pins on this side. Okay, now that kernel is in, and we'll see what happens now. The dead test is running like before. I should have perhaps tried the new DES test, but I haven't really gotten around to making one. DES test max. Okay, let's see now. Did this fix the machine and make it boot? Yes! So there's no issue with the address bus after all. That weird signal was obviously normal, or maybe some interference or something, I don't know. Yeah, so this works, but still I have the spare VIC-2 chip and the CPU, so I need to check the ones that was in the machine. The machine now works fine. It's all the chips that were in this board originally, except for the kernel ROM. And it seems to be working. Let's hook up the test harness and the diagnostics cartridge, see if the ports and everything is working. There can still be some faults hidden here. For example, the CIA chips can be damaged without preventing the machine from starting. For example, disk operations and the cassette can not function. Alright, let's see now. It looks good so far. Alright, we have a bad user port, U2. That's not uncommon. However, user port, I mean the testing harness, it obviously works. Can be a bad contact. Try once more. Well, I cleaned up everything and disconnected and connected, and still we have a faulty U2. That's one of the CIA chips. And that's this one. So yeah. Then we need to remove that and replace it. Not quite finished yet. Hey, I figured I didn't actually clean the cartridge connector and the diagnostics cartridge itself, and it was quite black on the pins, so yeah, now everything is okay. I thought it was a little strange that it reported the user port and the U2 faulty, when in fact the whole diagnostics harness is connected to the user port. So no need to change the U2 CIA chip. I'm gonna let it run for a couple of hours, see if it runs stable. But after that, I'm gonna take a look at this cassette drive. That's very ugly, but hopefully it's working and can be restored a little bit. Alright, there's still a little bit more to do on this board. I cleaned it up now already, so it's shiny and clean. I cleaned all the ports with some contact cleaner. Usually I do recap these ports, but I'm not going to do that now. I think this video will be long enough. I'm going to do that sometime later, I think. Only thing I'm going to do is to add a couple of heat sinks on the chips that usually gets warm, and that's the CPU and the SID and the PLA. The other ones not so necessary. Then I'm gonna assemble the machine and take it for a real test, and then we're gonna take a look at the cassette player, so please stay on. Made a little mark for future owners of this machine so they remember me. When I think of it, I haven't really tested the keyboard, but I'm pretty confident it's working okay, unless there's something electrically wrong with it. Just so I know what I did. And the label is back there and there, so yeah. Now this C64 looks as good as new, don't you think? How about the keyboard? Yeah, very nice. I hardly need to touch the keys. Usually on old Commodore 64s that haven't been serviced, you need to press hard. I have several of those. So that technique with rubbing those plungers, it's really nice. Alright, let's test the Le Mans game that came with it. I'll just clean up the cartridge with a Q-tip with some contact cleaner. Yeah, it's quite dirty. And I'm gonna try the joystick that came with it. But maybe that game uses those game pads. F1 or button on paddle. Yeah, I don't know if this joystick can be used on this game. Nope, no joystick, but you can use a keyboard obviously. Alright, let's try the paddles. These look alright. Probably not used a lot. I guess maybe since this came with just that one game and these paddles, that's all they really had for this computer. I'm not sure if it's port 1 or 2. I'm gambling on port 1. Let's see now. Press button on paddle. Yeah, that one worked. Okay. Yeah. Oh, it's a little bit scratchy. But the button works okay. But the potentiometer is very scratchy. I'm gonna open these up and try to clean them up. Yeah, I'm gonna do that right away. The cassette player can wait a little bit more. Yeah, these are really simple devices. Simply just a potentiometer and a button, that's it. 470k potentiometer, it says there. These actually uses some analog registers in the SID chip to work. Just gonna spray some contact cleaner. I'm not sure how good it will reach inside. I mean, if it's closed or possible to get something inside them. That should do it. Now just turn them around a lot of times. Let's see if we can do it in tandem. Double duty, save some time. Yeah, and these buttons too. Yeah, these were quite dirty. Yeah, that's better. A little bit at least. A little wobbly, but much better than before. I think with a little bit more turning, then they'll be perfect. Oops. What about that joystick? I'm running this from the Kung Fu Flash 2 cartridge. I showed that in a video a while back. You should take a look at that. Yeah, fire button works. Oops. Yeah, the joystick works. It's a little bit bad in the right direction. Need a joystick tester to test this properly. But I think I'll leave that for some time later. Alright, so let's take a look at the cassette player. Seems like all the buttons function properly, like they should. Very yellowed. I'm gonna clean it up a little bit before I test it. Computer cassette unit, and it says it weighs 700 grams. That's nice to know. What's this? Okay. A little bit stuck. Some clips going on. Yeah. There we have it. I just remove it completely from the plastics. Gonna take the plastics down in the sink for a little bath. Yeah, the mechanism, it looks alright. Belts are there and still intact. A little bit dirty, but obviously that's normal, but not at all the worst I've seen. And just clean it up all over the place with some IPA and clean the heads and yeah, the capstan and this roller. Yeah, that's better. All right, it cleaned up nicely. However, the yellowing I'm just gonna put it outside when it's cold weather with sun, and that usually helps. A couple of days of sun and it should be better. Let's test it. I'll use this Turtles tape that I'm always using when I'm testing these cassette drives, because it usually works. If the drive works, then this tape works. Yeah, seems to work so far. Found Turtles. Yeah, this seems good. The tape, it sounds alright. It's not particularly noisy, it just sounds normal. Yeah, that loaded fine. Excellent. Yeah, and then this game, to play it, you need a code sheet, which I don't have, but you can find that online. Alright then. Okay, February 2025. Yeah, just need to test a few games just to see that everything functions, and this game is quite demanding if I understand it correctly, but it seems to be working just fine. And this game, yeah, of course, this is Super Mario Bros. Yeah, this is a demo, Downfall. Alright then, that was it for this video. Always fun to repair a Commodore 64, and this time it went quite smoothly, I think. Struggled a little bit in the start, but finally it resolved itself. Hope you enjoyed it too. If you want to support this channel, I just ask you to check out my Patreon page, and there you can support the channel via membership there, and then you can get early and ad-free access to my videos. Finally, I just want to say thanks for watching, and thanks for all the subscriptions and likes, and special thanks to my patrons and YouTube members. See you next time. Bye bye.